Hello everyone. In last class we have seen the steady state stability. In this class we are going to see the transient stability. So what is transient stability? So in power system there are lots of disturbances. These disturbances are small type, these disturbances are of big type also. So if the disturbances are small and the system is able to regain its stable state or steady state, that stability is called as a steady state stability, that we have seen in the last class. Now in this, if the disturbances are large disturbances, the faults taking place in the system are large faults, then the stability which is achieved by the system, that stability is called as a transient stability. This equation is a power angle, this curve is a power angle curve, and with the help of this power angle curve we are going to explain the transient stability. First of all, see what is transient stability. So many sudden disturbances like fault, changes in transfer reactance due to switching, sudden change in load may cause system to lose stability even when the system is being operated below its steady state stability limit. The maximum power transfer is limited by the requirement of maintaining transient stability. So these are various faults these are the various faults which are occurring in the system. So these are change in transfer reactance due to switching, sudden change in load, they may cause the instability. So let us see. This is the power angle curve in first quadrant. It is plotted delta versus P. What is delta? Delta is nothing but it is the angle, it is the angular displacement of the rotor from the synchronously rotating reference axis. On x-axis we are taking angle delta, in the y-axis we are taking the power. This power is the electrical power as well as the mechanical power, because in transient stability studies or stability studies we are considering that electrical output power is always equal to mechanical input power, that is the system is a lossless system, and we have a swing equation PA equal to PM minus PE or TA equal to TM minus TE. So PA stands for accelerating power, PM stands for mechanical input power, and PE stands for electrical output power. This PA will be equivalent to TA. TA is called as a accelerating torque. PM will be equivalent to TM, that is called as a mechanical torque, and PE will be equivalent to TE, that is called as a electromagnetic torque. Now let us say that the system is operating at delta 0. The system is stable. This figure shows that, from this figure we will consider that the system is operating in steady state at Pi, that is input Pi will be equal to Pi0, and the corresponding angle is delta 0. So at this instant mechanical power is equal to the electrical power, so the difference between PM and PE is 0. So PA is having a 0 value, and whenever PA is having a 0 value, the system is said to be stable system. So we are considering that the system is a stable system and it is operating at an angle delta 0 and delivering the electrical power as Pi0. Now let us say there is a sudden change in mechanical input. So whenever there is a sudden change in the mechanical input, this PM is going to increase. The PM will be higher than the PE. So this delta doesn't respond quickly to these changes taking place on the input side, that is change in the mechanical input. So it will take some time. Why? Because due to the moment of inertia. So let us say that this PM changes from Pi0 to Pi1. So difference between Pi1 and Pi0 will be the change in the mechanical input. So due to change in this mechanical input, as the mechanical input increases from Pi0 to Pi1, so PE at this instant, PE will having a lesser value than the mechanical input power. So as PM is having a higher value, PE is having a lower value, PM minus PE will have a positive value, that is there will be a some value for this acceleration or PA, that is accelerating power, and that value is a positive value, and whenever positive value is there for PA, the rotor will start to accelerate. So I will say the rotor will start to accelerate in this direction, and when this rotor comes at this position, that time what will happen? The corresponding angle will be the delta 1 and the corresponding power will be the Pi1. Now Pi1 is same as the mechanical power and electrical power. So at this instant I will say mechanical input power becomes equal to electrical power. So the system should be stable at this point, but due to movement of inertia, rotor movement of inertia, this rotor will not stop at this position. It will move in the forward direction, and let us say it will come up to this point. So from when rotor is moving from this point to this point, the electrical output power will go on increasing, that is electrical power will be more than the mechanical power. So the difference between PM and PE will be the negative, because PE is greater than PM. So at this instant, let us say the corresponding angle is delta 2. So up to this point rotor will accelerate, and at this point it will start to decelerating. Why this is decelerating from this point only, we will say afterwards, but this is the point where rotor will start to decelerate in this opposite direction, and it will come here. So that is due to movement of inertia of the rotor, it will not instantly become stable at this point, but it will oscillate around this point in forward direction as well as the backward direction. Forward direction is called as the acceleration period, and this is called as a deceleration period. So this will oscillate at the final position, and it will become stable after some time. When oscillations are damped, it will remain at this point, and the corresponding angle is delta 1. So the system now become stable at the new operating state, new operating point, that is delta 1. So this is called, such type of stability is called as a transient stability. So in steady state stability we have seen that though there is change in the input or output, the system is becoming stable at the original operating state. But in transient stability, after being applied with the disturbance, when disturbance occurs in the system will become stable to the new operating point. That stability is called as a transient stability. Now what will be the maximum limit of the transient stability? In a steady state stability we have seen that the maximum limit is 90 degree. The maximum limit is 90 degree. Beyond 90 degree the system can't become stable. It will move into the unstable mode, or it will move into the out of synchronism. But here what will happen if this system goes beyond 90 degree also? What happens up to this point? What is the electrical power? Electrical power is more than the mechanical power, and after this point the electrical power goes on decreasing. electrical power goes on decreasing, that is electrical power becomes less than the mechanical power after this point. After this point, mechanical power is greater than the electrical output, so PA is having a positive value. So PA is having a positive value means rotor should accelerate, and whenever rotor accelerated, there will be increase in the delta angle. So after this point, I will say that the system will become unstable, it will not become a stable system, or it will lose synchronism after this point, because electrical power goes on decreasing, mechanical power is same, but PA will have a positive value. As PA is having a positive value, the rotor will accelerate, and due to acceleration there will be further increase in the angle delta, and due to further increase in the angle delta, the acceleration power will again go on increasing, and it will move out of synchronism. So I will say delta M is the maximum angle up to which the transient stability can be achieved. So that delta M is more than the 90 degree. So this is the difference between steady state stability and the transient stability. So everyone